Hey everyone! Welcome back to the channel. In today's video, we're going to dive into one of the oldest and simplest routing protocols used in networking. Routing Information Protocol, or RIP. We'll explain how it works, where it's used, and walk through an example configuration. Let's get started. Routing Information Protocol, or RIP, is one of the oldest distance vector routing protocols. It was developed in the 1980s, making it one of the foundational protocols in networking. RIP was designed to allow routers to exchange routing information to determine the best path to a destination within an internet network. RIP is based on a very simple metric, the hop count. A hop is simply the journey of a packet from one router to another. So in RIP, the metric that determines the best route is the number of hops a packet has to traverse to reach its destination. However, RIP has a limitation. The maximum hop count allowed is 15. This means that if a network is more than 15 hops away, RIP considers it unreachable. This makes RIP ideal for smaller networks, where the topology isn't too large or complex. Now let's talk about how RIP works in practice. RIP is a distance vector protocol, which means that routers periodically share their routing tables with neighboring routers. These routing tables list all the known destinations in the network, along with their corresponding hop count. Every 30 seconds, RIP routers broadcast their routing tables to all directly connected routers. This is done via multicast, and these updates contain information about the best known paths to various destinations, along with the number of hops required to get there. When a router receives a routing update, it updates its routing table and recalculates the best path to a destination. If the new path has a lower hop count, it will replace the old one in the table. For example, if router A has a route to 192.168.2.0/24 with 2 hops, and router B advertises the same route with 3 hops, router A will keep its route because it has fewer hops, which is considered a better path. As I mentioned, the metric in RIP is the hop count, and it has a simple rule: the more hops, the worse the route. The best possible path is the one with the fewest hops. However, there's a big limitation here. RIP doesn't take into account link speed, congestion, or any other factors. It's purely based on hop count. To put it into perspective, if you have a path with only 1 hop, that's considered the best. But if your destination is 16 hops away, RIP won't consider it at all, because 16 hops is above the maximum limit of 15. RIP also uses timers to manage routing updates and table validity. These timers control how often routing updates are sent and how long a route stays in the routing table. The most important timers in RIP are: first, the update timer sends a full routing update every 30 seconds. Next, the invalid timer. A route is marked invalid if it hasn't been updated in 180 seconds or 3 minutes. Then, the hold down timer. This prevents a router from accepting new routes if the original route has gone down, allowing the network to stabilize. Lastly, the flush timer. A route is completely removed from the table after 240 seconds of being invalid. These timers help RIP manage routing loops and ensure that routers are working with up-to-date information. RIP does have some significant advantages, particularly for small networks. Since it's a simple protocol, it's easy to configure and doesn't require a lot of resources, making it ideal for networks that don't need complex routing decisions. However, RIP also has some limitations. The 15-hop limit makes it unsuitable for large networks. It also has slower convergence compared to more advanced protocols like OSPF or eDRIP, meaning it takes longer to adapt when the network topology changes. And because RIP relies only on hop count, it doesn't account for factors like network speed or link reliability. So where do we use RIP? As I mentioned earlier, RIP is best suited for small to medium-sized networks where the complexity and size don't demand sophisticated routing protocols like OSPF or BGP. You'll typically find RIP in smaller offices, branch offices, or environments where ease of use is more important than scalability or performance. It's also great for learning purposes, as it's simple and intuitive. Now let's look at how you configure RIP on a Cisco router. Here's a simple example. First, we enable RIP with the command. We set it to version 2 since version 1 has some limitations, especially with IPv6. Then we use the command to specify which networks we want our IP to advertise. Finally, we use the command to stop RIP updates from being sent out a specific interface like Gigabit Ethernet 0/1, which might not need RIP updates. So, to wrap it up, RIP is a simple, hop count-based routing protocol that's great for small networks or learning how routing works. However, its limitations, like the 15-hop maximum and slower convergence, make it less suitable for larger, more complex networks. If you're working with a small network or just starting out in networking, RIP is a good choice to get familiar with how routing protocols operate. Thank you for watching today's video. I hope you found it helpful. If you did, be sure to like, subscribe, and leave any questions or comments down below. Until next time, keep on learning and happy networking. Sign up for InVideo AI through below referral link and get an exclusive bonus 50 AI minutes. Also, please let us know in the comments if you have a suggestion for our next video, and if you enjoyed this video and want to see more content like this. Make sure to hit that like button and don't forget to subscribe our channel so that you won't miss any of our future videos.